the people in this treatment group gained almost 4 IQ points more than the control group after 1 year. So students who were in this classroom that the teachers were tricked into believing were special kids had better education outcomes compared to kids who are like in the normal class and teachers thought were normal.
Right.
And so the only difference really is what the teacher believed. It's the expectations of the teacher. But don't you think if what your OC class was turned into a high school, you probably would have gotten a better experience compared to going to James Lewis?
Ooh, oh, that's a very controversial statement.
Well, welcome back and hello to new viewers, right? So, my name is Anthony.
I'm Wayne.
And we are the founders of Atlas Academia, which is an organization we created to advance or to advocate and support science education in New South Wales. So, in general, we really want to advocate for education empowerment in general. We believe the important thing about a real education is to empower students so that they have the confidence and skills to achieve whatever they want to be doing in their lives. Mm-hmm. And for us ourselves, we are practitioners in science education, so that's more our specialty. We want to do that using science as the instrument. But we want to champion all subjects, obviously. You need to learn everything if you want to be successful. This is a podcast we created. The objective is we want to be spreading new ideas to people, and specifically high school students, those of us that are studying with us, as well as just high school students in general who are interested in the topic of education and want to get more out of what they're doing in high school. So what we want to do is really share a lot of interesting ideas, particularly things that are rarely discussed about for high school students. Some examples being, the things you should actually be doing in school, really questioning the purpose of education and trying to talk to people in really interesting areas that you might not be able to talk to in general. People like teachers, hopefully people with a bit of experience with the HSC or as part of NESA. There's people in all these different facets of the education system to try and unpack this complicated, system that we all work in.
Yeah. So in short, look forward to some special guests such as ex-teachers, current teachers,
school alumni,
researchers.
Yes. Right. So we'll try and bring on a large variety of people and also have a bunch of episodes with just us and other fellow staff members who are trying to keep it casual as well.
Yeah.
But we want to get right into it, right? So today, and I think for a few of our future episodes, one thing Wayne and I really want to unpack slowly with a lot of care is this report called What Works Best. And I think Wayne's probably in a good position to introduce what this is actually about.
Yeah, so a few months ago, one of our good teacher friends showed this report to us. It's from CESE, C-E-S-E, the Center for Education and Statistics...
And Evaluation.
And Evaluation, yeah. Education, Statistics and Evaluation. And in 2014, they released this report called What Works Best. Mm-hmm. And it's sort of like this evidence-based sort of guideline for
how
teachers.
To teach.
Yeah.
It's a guide on how to teach, basically.
Exactly. And so it's essentially just a 40-page report with 8 key themes, key ideas for how teachers should teach. Today, we're going to look at the first of those 2 themes. But Anta, do you want to introduce all of those 8 themes first?
Yeah, cool. So these themes are, there are things we believe in, right? So we had to read through the report and we're like, nice. This seems to align with what we were thinking works best in terms of teaching practice.
Yeah, because we have a few years of teaching, obviously not much experience, but even in these few years, we've sort of stumbled along to find the methods that really work, right? The things that we think are very valuable in order to teach. Originally from a coaching environment, but building that more and more into a more sort of holistic education environment. And so when we read this the first time, it was actually really, really satisfying, I guess. Yeah.
A lot of validation.
Yeah, to sort of validate that these things that we stumbled upon ourselves were actually also the evidence-based, real things that real teachers are being told to do.
Yeah, exactly. And the point is not to try and prove that we're the best or anything, right?
We're not.
When we talk about these, you'll probably see the themes make a lot of sense. There's nothing particularly controversial about them, but it's this idea that we're all on the same path, but our job now is to expand upon them. Now that we know the basics, how can we refine this to the absolute limit? How can we best apply this principle besides just mentioning it? right?
Yeah. So, what are these 8
Yes.
themes?
That's why I actually introduced them. So just to read them out, and we'll try and spend a lot of time really unpacking them properly in future episodes, right? We have theme number 1, high expectations. Theme number 2, explicit teaching. Okay. Theme number 3, effective feedback. Theme number 4, use of data to inform practice. Theme number 5, assessment. Theme number 6, classroom management. Theme number 7, well-being. And theme number 8, collaboration.
Yeah. And for those of you who are watching who are enrolled students with us, you'll have seen these around within the last few weeks. We've now, CZ have been great enough to actually make posters, A4 size posters for each of these themes that really quickly sort of outlines exactly what each theme is about. We printed them out, put them up in little places around the center as well. So it's a chance for, as we say, this podcast is about empowerment. It's about showing you guys sort of what these tools are so that you can use them yourselves, so that we can use them as well alongside you. You can understand it as well. So if you understand these as well, what a great chance. So the first of these 8 themes is high expectations. I think you've got a poster there, Anto. So do you want to put that up? Read what it's... Oh, gee, okay. Okay. Do you want to unpack this?
Yeah. So basically, the idea for this first theme is if teachers encourage or have high expectations of their students.
And parents and carers.
Yep, that's right. If everyone involved with a student's education has high expectations of them, it seems to be that the student achieves an improved outcome in their education. Right? That's sort of the basic claim. Let's try and unpack that and to understand what that actually looks like. I guess firstly, what even are high expectations?
Is it just the teacher or the parent or the carer saying, I have high expectations of you, you're going to go and achieve great things, or is there a bit more to it?
Right. So I'll first start with how this report tried to quantify high expectations. Some examples of those, I think I definitely have a few to talk about later, but we'll just start about how they actually did the stats for this, right? So from what I could tell from the report, there were sort of 2 ways they actually got information about high expectations. But basically the primary sort of source of data, it seems like, is from the Tell Them From Me survey. A lot of the data seems to come from there. So a lot of what was looked at was the idea that students had to answer questions like, my teacher has high expectations of me, and whether the students agreed or disagreed with that statement. So that's sort of one way they found examples of high expectations.
Right. And then presumably they used the students' marks and things to correlate that, right?
Yeah, so there was some really interesting stuff regarding things like NAPLAN results and PISA results.
Do you want to quickly elaborate? What's PISA?
Right. So PISA, I forgot the acronym, but it's a high school ability assessment thing. It's an international assessment, so it's one of those big things where you might read in the headlines Australia ranks bottom for numeracy or something. It's those it's not. But it's those headlines you always see when countries rank each other based on reading ability, right, numerical ability. From memory, that's what the PISA is about. So that's dealing with how good people are in high school, and NAPLAN is also a good measure of high school and primary school performance. So yeah, we can see the connection between students who report that they have high expectations in the classroom and their so-called NAPLAN outcomes and PISA outcomes, and things like that.
Okay. And obviously, neither of those 2 metrics are very much perfect, but
oh yeah, for sure, yeah.
You get a good enough sort of approximation with a large sample size, right?
Yeah, they're the actual proper purpose of standardized testing, which is to actually get decent enough information.
Kind of worms for another time.
Yeah, good point. Yeah, we'll leave that for another time, right? So that was one sort of way they got information about it. But another way, which I thought was really interesting, but I can imagine was really hard to do, was this study that was done in 1956, according to the report.
Wow.
Called they gave what would I say this? The shorthand name for it, the nickname for it, was called the Pygmalion in the classroom study.
Pygmalion study, okay.
Yeah, and to unpack that, just because I thought it was funny because it was a reference to something that we did back in high school. Actually, did you do it back in high school?
No, this doesn't sound familiar, no.
Okay, so I think in high school, maybe year 10 or year 11, one of the English texts we did was Pygmalion. And basically the context for that was Pygmalion was first some ancient Greek tale or something, myth or something like that. But basically it's one of those things where a modern writer references something in their work. But basically the actual Pygmalion that we talk about these days, and I'm pretty sure the study is a reference to, is a play I just skip to the theme. The theme of the text Pygmalion is essentially a man takes this woman who's like very low class, speaks with like a really harsh accent. I think it's like set in England. It's like that sort of thing where like your accent tells you where you're from. So basically, like you could tell this woman was very low class, very uneducated based on her accent. And basically the premise was he would teach her. He was like a professor of linguistics or something, but he would teach her to speak like a posh person, like an educated person. And the moral of the story was that she was able to then pretend to like fit in with higher society.
Right. And it works, right?
Yeah. So basically it's like can you trick someone into being someone that they're not, right? Can you put on like a surface veneer and get people to believe that someone is actually something that they're not, essentially.
Right. That does sound very reminiscent of the high expectations for students, right?
Yeah, and so like why this is relevant to the study was what the study was I think it was elementary students. I can check really fast.
The classroom study.
Elementary school students. And so essentially, a bunch of elementary school teachers were given a classroom of students. And this was a random assortment of students, right? But the teachers were told, deceptively, that these students were identified as essentially gifted and talented students. So they might not actually, because they were just random students, but the teachers were told that these kids were meant to be special. And so the teachers sort of knew that in their minds, and they sort of started teaching the students normally. And so obviously the idea is like, what sort of implicit biases did the teachers have, and how would that have affected their teaching? And the results of the survey, or the study, was that, let's see, I think 1 year? Yeah, and I'll just read out the results. So the people in this treatment group gained almost 4 IQ points more than the control group after 1 year. So students who were in this classroom that the teachers were tricked into believing were special kids had better education outcomes compared to kids who are like in the normal class and teachers thought were normal.
Right.
And so the only difference really is what the teacher believed. It's the expectations of the teacher, right?
Yeah, and presumably those expectations guided how the teachers treated their students. For example, maybe like giving them more extension work or things like that.
Yeah,
right?
exactly. And I think this is a really interesting study because, like, just firstly, in terms of the logistics, man, that would be hard to do. Like a 1 year study, you have to like randomly sort these kids. You have to find a classroom to monitor. You have to give teachers these kids and then check up on them in 1 year's time. So like, that's just impressive.
And the ethics sounds pretty dubious as well.
Yeah, right? So that's just cool, right? And the result is very interesting. You know, I don't know what 4 IQ points more than control actually like, you know, I guess the concept of IQ is a bit dubious as well.
There is no perfect metric, but
yeah,
you deal with what you've got, right?
Yeah, like I think most people will not find it controversial to say that the conclusion is the kids in that group ended up a little bit smarter than the people in the control group. But yeah, I think that was a really interesting example of actual evidence supporting the potential benefit of high expectations to students. But yeah, one thing I thought was really interesting was when I was first reading through this, I saw that a lot of examples were like all over the place in terms of this is an example for elementary school students, this is an example for high school students, right? But in a way, that's actually a good thing. It seems like one of the big conclusions of the study were that high expectations are beneficial to students at every level of their learning. So, you know, some other things that I'll skip over are like some other metrics were definitely improved NAPLAN and PISA results, as we mentioned. As we just saw, better IQ scores, it seems like, for developing children. I mean, one interesting thing that I didn't see many specific examples of, but one of the studies mentioned talked about how students had improved post-school aspirations as a result of high expectations. And like, that's something that I think is very near and dear to us, right?
Yeah.
Because like, once again, this whole theme of empowerment, this is what we're aiming for. We want kids to have the confidence to go for what they want. And it seems like high expectations has a very clear influence on this.
Yeah. To be fair though, on the other hand, I think like how the high expectations manifest in the actual classroom environment and sort of in the attitude of the teacher and carers is obviously going to have a big impact, because I could also see an example where, for example, high expectations may lead to student burnout or student mental health issues, right?
Yeah.
So surely it's a fine line, and I'm sure we'll talk about this, but like I would like to also see what the sort of specifics of a high expectation should actually look like, I guess.
Yeah, that's a good point, right? I think it's something that we definitely noticed when we started reading the report the first time, which is like, if someone just says blanket, like across the board, high expectations are good for students, you know, you're like, ooh, wait, hold up.
There's got to be caveats, right?
Yeah, right. And I think one of the big takeaways it seems to be from this theme is that it's not just saying, I expect you to do better, right? Like, it's not just high expectations like that, but it's significant actions that the teacher takes to support that. So one interesting thing that came out of the report was this idea of direct and indirect effects of high expectations on students.
Okay.
So in terms of direct effects, it's this idea that a teacher can't really demand higher expectations of their students unless they change their teaching to support that as well. So instead of just saying, I expect you to do better, right? If you do have high expectations for your students, you need to actually sit down and write harder questions. You need to find resources that maybe contain extension content, right? And you can't just be like lazy about it and tell them to find it themselves. You need to do the work to curate those, to pick ones that make sense, that are not going to lead them into a random hole.
Yeah.
Right? So
Well, actually,
it takes effort.
Yeah, I mean, like, 'cause that you saying that leads me to thinking about what we sort of do in the classroom. One of the things being which sometimes there are concepts that are really hard to understand, and maybe even understanding them is potentially outside of the scope of what we're meant to teach. But
Yeah.
if we can help the students, or at least give them the chance to be able to understand that, that's an example of the high expectations that may be better for their learning outcomes, even if, again, it's not necessarily within scope.
Yeah. And I think another thing that helps is probably like, I think it's two things. It's probably the culture of the classroom, if the kids are willing to sort of push themselves for it. And to sort of support that, the second thing is more like the implementation of high expectations. Like, there's a big difference between just like giving everyone a test and then giving it back, be like, you guys are crap, right? And the teacher saying, okay, from what I know, what I've seen from experience, when I have high expectations, my students do better. I want to be tougher on you guys, and I want to expect more from you. And I think it will, like, if you can play along with this game and you can push yourself as well, I think you can do better as well.
Precisely.
Then I think for the most part, the students aren't going to just burn out and be like, no, this is impossible, right?
Fair enough.
So one thing that I really want to discuss and maybe share with our audience are examples anecdotally that we've seen ourselves of where high expectations have been pretty good for either our own development or those of our peers.
Right, so even as students and as teachers. That sounds good. As long as we approach it with the caveat that as students, we did go to James Roos.
Yeah.
So it was obviously quite a biased sample of not just all the students, but let's do it.
Yeah.
You can start.
Yeah. So I think I have one example that I think is quite like unique, I guess, because I think we also have a lot of common examples that come to mind of like classic scenarios of just selective schools in general and things like science Olympiads, which we'll probably talk about in a bit anyway. But one thing that I always thought was quite unique about my experience was actually my OC experience back in primary school. So on the off chance that there are listeners who are not from New South Wales, because I did a quick Google search, I was like, how big is the OC? Like, do people know about this?
Yeah.
So for context, OC or opportunity classes are a thing in New South Wales primary schools where in years 5 to 6, you can be in a special OC class that you were selected for after a standardized exam. It's basically a selective school, but for primary schoolers, right?
Yeah.
And there are a bunch of different OC schools out there. And they kind of get free reign on how they do OC.
Yeah.
And I think one thing that's really interesting is, like, selective schools, they all kind of fit the same mold because it's all for the purpose of, honestly, getting a good HSC result. We can sort of debate the usefulness of that. But, like, the selective schools know the game they're playing. Whereas OC definitely seems a lot more variable. Like, it was more like the teachers were told to keep the gifted and talented kids occupied.
Yeah.
Right?
Well, I mean, not necessarily. I'm sure it was more, there was also just like extension and like sort of helping them find who they are in a sense.
Yeah. And I think it's also interesting to get your perspective on this because I don't remember which type of experience you had in OC, but I think I had a really positive one. Just to check with you, what did you think?
Yeah, I also went to OC, Artarmon Public School. Also a very positive one. I think partially because of the environment, the culture of just having other high achieving students. Again, like the high expectations there obviously are with the teacher, but they're also implicit within the students themselves because everyone knows they're in an OC class.
Yeah.
Right. And then obviously the other great thing is, yes, the teacher there, a nurturing teacher, and potentially someone, like, because a teacher who's picking that up most likely is doing it because they're more passionate about this, right? This is something that they want to do. So I think I benefited from that as well. Yeah.
Yeah, okay, good. So we're both positive examples. To be honest, maybe it would have been nice if one of us had a negative experience, but that's okay. But I could definitely see the things in OC that helped me going into high school, for sure, were like very valuable.
Yeah, strongly agree. Like, because it's like in OC, there were so many just different random projects. Like we ran a mini class medieval society,
Yes.
like a gold rush thing.
Yeah.
We had
We had a gold rush thing as well. Yeah.
Earth's Parliament, which was basically trying to run your own like little countries and stuff.
We did a run for New South Wales Parliament. So,
There we go. Yeah, and like extension activities, writing and giving speeches on a regular basis, things that are meant to be there to push a student holistically.
Yeah.
Right. It was definitely very helpful.
Yeah. Seems like we actually had very similar experiences, right? Like this sort of project-based, like here's a theme for a few months or a whole term, just do various things that are related. Like it wasn't like we're doing science, we're doing maths, we're doing arts, right? It was just like, here's a project, just use everything and do it.
Yeah, and it's immersive, gives you freedom to be creative, gives you freedom to sort of, like, whether you do like the science part of the medieval society or the economics part of the medieval society more, like it gave you that reign, right?
Yeah. Yeah, there were some really good things about that. I remember, I think one of the easiest examples that come to mind is one of our themes we did for a bit was MC Escher, the mathematician / artist, all the tessellating shapes.
Yeah.
And a really cool thing my teacher had was basically, she had like a list of projects you could do. And I think it was like you had to at least do a certain number of them. But they were like all across the board in terms of what sort of subject they pulled heavily from. So if you were a really artsy kid, you could be like, oh, your project is to create a bunch of different tessellating shapes, like do an art project. Or if you were a bit more of like, the researcher type, you'd be like, oh, you now have to write a report on the history of MC Escher, right? And so you could like pick and choose the ones you liked and do those.
I mean, I am totally wary that we're sort of just being in an echo chamber here, but that's precisely what I remember being great about my OC. Like for our Earth's Parliament thing where we ran our own countries, I was the person who was interested in sort of designing cities. So I built our whole little city on SimCity. Someone else wrote the national anthem for it because they wanted a chance to get musical. Someone else was in charge of the economics behind it and like the sort of political law, societal rules and things. It was an excellent opportunity, and it all just came about because a teacher was there saying, yeah, these guys are smart enough to just give them the full beans, give them the chance to go nuts.
Yeah, exactly. And I think this might be a controversial statement, but I feel like I vaguely remember I've talked to you about this before back in high school. But don't you think if what your OC class was turned into a high school, you probably would have gotten a better experience compared to going to James Lewis?
Ooh, that's a very controversial statement. I'm not going to say which one's better, but I'll tell you what, if high school was as immersive and project-based holistically as OC was, I think I would have enjoyed it a lot more, and I probably would have developed more holistic skills.
So you technically answered the question.
I said nothing.
Danger zone. But yeah, right. Anyway, but so that was an environment that was very challenging and very engaging.
Yeah.
And I think one thing that was really crazy is that I know for my cohort of people who went through that class, like I'm always like shocked in terms of just how successful everyone from my class is. Like I remember thinking back to the people who came from Summerhill and what they ended up doing like after year 12 and stuff. And it's honestly astounding. Like just to read off the list, imagine, okay, so I'm pulling from a list of like 40-ish people maybe. And these are like only the people I know what they're doing, which is only a small fraction. There's firstly, just I guess to get the boring one out of the way, a surprising amount of them got very high ATARs, like easy 9.5s or 9.0s, 99.95, 99.90, right? But that's fine, that's boring. Like we had an international maths Olympian, we had an international chemistry Olympian, we had an international physics Olympian, and the dude who did physics got the first gold medal in like a decade or something longer for Australia. We had a bunch of super musical people. We've got another maths genius who wasn't involved in maths Olympiad, but was also just, the dude who ended up like topping the state for 3-unit and 2-unit maths 1 year early. I think those are the main ones that come to mind, right? But like just from such a small classroom, like just the ridiculous amount of academic as well as non-academic success that came out of those classes is insane.
Yeah.
Like I think that's where I first had that joke or idea come to mind about like OC class versus high school. Because I was like, if you extrapolate, if you take like the body of the OC class that I went to and you scaled it up to a high school size, it would probably have ranked higher than James Lewis in terms of academic success.
Controversial statements,
right?
but okay.
You know, that's when I realized, I was like, wait, I get downgraded when I graduated, right? But like, it was all about, and it wasn't even like high expectations in the crazy, what some people might be thinking, like, I want you to do better, you're garbage, sort of thing. Like, it's just like you get the chance to excel and you're not babied.
Okay, but let's stop right here. This is a very good time to stop because we could honestly talk about how good OC is for the whole time.
Yeah.
The caveat with this is OC is an example, and it's a good example, but it's an example of high expectations working really well for existing high achievers, right? So you're already taking the top of the cohort.
You just boosted them further.
Yeah, and that's good because it's probably quite an obvious revelation to say, obviously for high achieving students, if you sort of limit them to a core curriculum, they're not going to perform as well as if you allow them to sprout and to sort of grow freely. But I want to see an example of where high expectations help not just those cream of the crop, but actually can help everyone wherever they are.
Yeah. Well, I guess for those, it's hard for us to draw from anecdotal experience because we were not in those situations, right? But I think it speaks to the fact that, the people who are advocating for higher expectations are not randoms like us, but are people who are part of the government who have studied, like, across the board, high schools, and have taken data from primary school and high school success, and have said, okay, one of the big 8 themes that we're going to tell teachers you should do to be a better teacher, on average, is to have high expectations. So I think it's less exciting as a story, but all those improved NAPLAN, PISA results, and things like that are very strong evidence that, even on the more average or below average level, high expectations. So just to pivot on something completely different, because there are lots of different points that this report raised. So we've talked a little bit of examples where high expectations have been good. One thing that I found really interesting to read from the report was essentially just the trends that they noticed about high expectations. And, they're a little bit troubling, but they're kind of what you expect, where one unfortunate result is they seem to find very clearly that, firstly, we now hopefully agree that high expectations across the board generally leads to improved outcomes for students. They also found that high expectations are much less prevalent in schools with a lot more disadvantaged students, particularly those from lower socioeconomic status, and actually even worse for those of Aboriginal and Torres Strait Islander origin, right? So people from those disadvantaged areas are lacking or don't receive as much of this thing, high expectations, which all of our research has told us is actually a good thing for doing better at school. So it's very unfortunate, right? But I guess a very similar thing that I want to unpack a little bit is another trend was they found that high expectations decreased as students progressed further along their schooling. So I scribbled down some percentages, but it seems like when, from the Tell Them From Me survey, I believe, they found that about 95% of primary school students answered yes to the sort of question of, my teacher has high expectations of me, which is quite a big percentage in general, actually. But so 95% for primary schools, and this dropped to about 70% for high schoolers in year 10, right? And it rose up a little bit. So from the graph to sort of describe it, it kind of flatlined out constantly in the 90s across primary school. And then the moment you hit high school, it was like this linear drop down to its worst level, which was about 70% for year 10s. And then went up a little bit to 80% for year 11 and year 12. Probably correlated with teachers finally needing to push their students to do stuff for exams. Yeah. But like, still, that's a big drop off percentage wise.
That's really interesting. And like, honestly, I could sit here speculating multiple reasons for that. Like, for example, you're going from having basically one teacher to look after you to multiple teachers where there's less accountability for each student from the teacher.
Yeah.
And then also just the move to high school and people being like, oh, the move to high school is hard. Don't expect it to go great immediately and give yourself some time. Damn, that's really interesting.
Yeah. And I think it's some good evidence for, honestly, one of the things we advocate for, which is to try and get, what we believe, at least, we think high school teachers should be trying to have higher expectations of their students. There's this sort of message or culture behind the scenes of, oh, science is meant to be hard. You're not meant to get it. You have to memorize these things, right? And we're trying to go against that. And I think that one of the first steps you can do to go against that is actually say, no, you can understand this, right? Right? If you put in the effort and you try your best to learn properly, this is doable. This isn't some impossible, you can only be a genius to succeed sort of thing. This is bloody year 12 chemistry. It's not that hard, right? But I do see, like, as you said, it makes a lot of sense that this drops off. Because if you think about it, right, if you're in primary school, let's say you're in early primary school, and you give a kid like like a times table question, right? The kid does it, right? You don't say like, oh, good job, don't do any more. It gets really hard soon. So just chill out, right? You go, okay, cool. Here's more times table questions, right? Here's like 2-digit times 2 digits, right? Like it makes so much sense. Like that's so normalized that if a kid in primary school can do a task you give them, you challenge them by just giving them more.
Yeah.
And the reason for that is obviously the teacher is very confident about that content, right? No teacher's like, oh God, I don't know enough multiplication to go to the next level, right? But in high school, it's a different story. Once again, I think I talked about this on a previous episode. We're not blaming teachers for not having,
I hope not.
For not being experts in like the more difficult fields. But you can definitely see, particularly in the areas of like science, right? If a kid gets what's in the syllabus, the step above is a little bit tricky and it might not be something that teachers fully understand. So they're not as able to just be like, oh, hey, Billy, you understand this? Try this, right? It's not something they can just make up on the spot.
Yeah, I mean, on the one hand, I agree potentially it's that, but I'm sure there's other factors as well. For example, just that there is a bit of a stigma that like sort of trying to accelerate content is sort of bad for you. And if you learn too much depth too early, then you're not going to have a nice breadth of holistic learning. When in reality, it's probably a lot more complicated than that.
Yeah, I think you're right. There's a lot of like hesitation, I guess, to sort of extend students. But I think the primary reason is expertise, right? By far, the students, the teachers who are comfortable to just go out of the box are the ones who have the knowledge to do that, right? But I think we should just be providing more opportunities to upskill teachers. I think that's the takeaway.
I will refrain from commenting. Okay, apologies for the break in continuity. I have a jacket on, it's very cold. Let's move on to the second theme, which is embedding explicit teaching.
Yes, go punch it on the wall.
I will not be punching it, I'll be lightly tapping it on.
Okay, I'll help you.
Another one where when I read it, it just makes me feel good because it's the things that we work so hard to do.
Yeah, exactly. So to sort of introduce what explicit teaching actually is, I found a good definition from the report that I think would be nice just to read out, sort of just like get into the mood of discussing it.
The mood.
Right? So, in explicit teaching, the teacher decides the learning intentions and success criteria, makes them transparent to the students, demonstrates them by modeling, evaluates if they understand what they have been told by checking for understanding, and retelling them what they've been told by tying it all together with closure.
Oh, that sounds brilliant. Yes.
Right? So it's basically like explaining what you're doing when you teach. That's basically the gist of it.
Yeah. If I can start with a quick example, like one of my favorite teachers, she always tells me about how whenever she runs practicals at school in the science department can sometimes go well and sometimes go badly, as I'm sure some of you students know. Practicals in the classroom, that is. Sometimes if you do a practical, and I guess sometimes there's this focus that you should learn by doing. And to a certain extent, like obviously that makes sense. Like students can't just be told how practicals go without actually doing it, right? Obviously you need to do the practical to build those practical skills. But at the same time, sometimes I feel like some teachers take that too far because the students will do the practical, but they won't actually understand what they've learned or what they've done and why they've done any of it, right? And so that's where that explicit teaching comes in. Because obviously you do need to learn by doing the practical. But then the good teachers, what they'll do is either before or after, they'll sit down with the students as well, analyze what they just did, talk about the steps that they just did, potentially explain why they did them, and actually sort of talk through the learning of that, providing the context for it, giving the reasons for it. And to me, at its core, that's really what explicit teaching is, right? It's telling you why you're doing something or helping you realize why and how you're doing something rather than just doing it.
Yeah, it's one of those things where I think the concept of like learn through play or inquiry-based learning has sort of gotten a lot of attention in recent times. And although there's a place for it, I think it's not like inquiry-based learning does not mean just dump it on the student and let them figure it out, And as Wayne said, you need some level of teacher direction to sort of guide students into realizing how to think about it. Or else, like, why did you need a teacher in the first place if the student could work it out?
Exactly. Like, the job of the teacher is to coordinate and guide that learning, and that's where this explicit teaching comes in.
Yeah, exactly. So, once again, the report outlines a lot of very significant statistics where, students that self-report that they receive very explicit teaching in class, and they could be very simple things. So some examples that I saw where students were asked about their experience in an English classroom. And, some examples of explicit teaching that were recorded were the idea of teachers giving a summary of what happened in the lesson, teachers setting very clear goals for what they expect of their students, teachers continuing to teach or work on a concept with students until the student actually shows that they can understand it, as well as a teacher continuing to ask questions to test whether students actually understand what's going on, right? So all this other stuff that isn't the literal explanation of a concept, but it's still valuable in the classroom.
Yeah, absolutely.
Yeah. But yeah, all of these have been shown from the report to correlate very heavily with improved results in various standardized testing like NAPLAN.
Yeah. And it makes sense. Like at its very simplest form, explicit teaching may well just be being able to just telling you what syllabus dot point you're learning today, right? And then obviously building upon that. Of course, that's going to be helpful.
Yeah. So I guess for us, maybe it'd be good for us to talk about how we try and incorporate explicit teaching into how we teach. I guess an obvious thing off the top of my mind is, basically working on the purpose of a concept with a student.
Yep.
It's something that maybe I place too much emphasis on, but I always like to, when I'm trying to work out how I would explain things, I sort of run this simulation between me and a student. And essentially, after every sentence I say, I'm checking the student to see what they would respond with. So, for example, let's say, this is off the top of my mind, but let's say, okay, I did this a lot, and I think it helps me a lot for trying to decode how to go about teaching the mole concept to Year 11 students, because that's a classic. That's a classic thing everyone struggles with, right? So if you start from where a teacher might normally start, you say, okay, the first formula is N equals M over MM, where N is moles, M is mass, and MM is your molar mass, right? Student then goes like, why, right? Like why do I care, right? So then I would go, okay, let's take a step back then. Today, we're going to learn how to do calculations involving moles, right? Which is a natural evolution. I do see a lot of better teachers start like that. They start to introduce the goal of the lesson. We're going to learn how to do this calculation, right? But then the student can still say, why? I don't know. Why do I care, right? So then I had to take a step back and go, okay, wait. So let's try and work out how much product is formed in this reaction. So the place I've settled at now is I basically say, okay, 10 grams of water reacts in this reaction. Let's say it's electrolyzed to make H2 gas and O2 gas. How much is formed? And then we go, okay, I can't answer this question. I don't know, right? So then I go, okay, well, how can we answer this question? Well, there are certain things we need to understand. There are certain operations we want to be able to do. So it almost starts with this purpose. Like, here's the challenge. How do we get there? And then after a little bit of work there, then I get to that earlier checkpoint, which is, okay, so you can see now the purpose of what we're going to do is to do this mole calc. And then after a little bit longer, then I finally get to, and that's why the first formula is N equals M over MM, right? So it's all this really early stuff that I try to focus on. Why a content is useful, why we bother learning it. Because it's the stories the students remember.
It really is. It's the story, right? That's a great example. And I think it ties in a lot to, like, most of this, not all of it, I'm sure. There's a lot. There's a lot to unpack. But a big part of explicit teaching is seemingly just context.
Context, yes.
Yeah, students need to have context, whether that's context within the syllabus, context within skills and things. And once you think about it as context, well, that sort of justifies a lot of the things of explicit teaching. So, for example, things that we'll be thinking about when we're writing a lesson and planning a lesson would be, okay, today we're learning these new concepts. Why are we learning these concepts? We need to provide that sort of context for behind it. What do you need to understand before you learn this new content, right? The students should know what the foundational knowledge you need for this content is firsthand. So whether that's helping your students revise that or at least helping them see that that's the case, right? And then afterwards, obviously, you need to get the students to help apply that and then also summarize what exactly we learned. How does that fit back into the grand scheme of things, right? All about context.
Yeah. When you said context, you wandered into my trap. Not really, but...
oh, no, what?
It's not actually a trap, but it's something I had at the back of the mind that I wanted to bring up in this theme, which was this concept of why context is important. And the reason why it's important is cognitive load.
Oh, cognitive load.
Yes, so
cognitive load.
That's a throwback to anyone who listened to our earlier episodes last term. But essentially, if we want to unpack unpack why explicit teaching is good, which I think is important because like stats are stats. You can say, oh, if you do this, you get better marks, but we all know like there could be confounding factors. This doesn't prove anything really, right? We want to understand on a first principles, on a logical basis, why it makes sense that explicit teaching is good. And I think one of the primary reasons that it is good is that it reduces cognitive load on the student. And that's something the report says very clearly. It says, explicit teaching reduces cognitive load on students. So I read that and I was like, hell yeah, we already talked about cognitive load on a previous episode. So really good synergy, right? And so just to bring everyone up to speed, basically, you have a certain ability or capacity to process information, your working memory. It's like RAM on a computer, right? And basically, you can, when you're given new information, you will use a certain amount of your working memory to understand the information, to process all the new information. What the hell is even going on? This is a graph. What do the axes mean, right? What's the trend, right? All that stuff. And you have another part, or you can dedicate more of your working memory to then retaining that information, to storing it into your memory. And so the idea is when you are learning, if you experience too much cognitive load in regards to processing the information, then you don't have enough working memory left to store it. That's when you can't understand concepts because they're too complicated, right? And so obviously, if you think about all of the working memory, all of this cognitive load that's going on when you're processing information, some of it you cannot avoid. Like that's the legitimate complexity that is associated with the concept. But so much of that difficulty is also just all the other context in the background, like, oh, what's going on? What's the purpose of this, right? If you're learning something and those questions are at the back of your mind, that is legitimate, like you are experiencing firsthand a wastage of your working memory in extraneous thought that is not relevant to understand the concept or committing it to your memory. Right? So that's very clearly why context does help so much in teaching. But so it all comes full circle, right?
Strongly agree. Strongly agree.
Like one big takeaway from this is that like it really doesn't pay off to be all mysterious when you try and teach. I think there is this, sometimes there's this idea that like you want to make science mystical or like seem very difficult in a way. And I honestly like don't really agree with that. Science should be made accessible, and it's made accessible with explicit teaching. It's not magic that something happens, right? It's very clear steps that lead to a final effect.
For the most part, as long as you don't lose them, because even if you're doing explicit teaching, at the end of the day, it can still, you can understand all the processes, but it can still seem magical. And that magic is also, it's hard to quantify and it's a bit hectic, but it's also nice to just see the magic. And it's just, it helps you feel good, doesn't it?
I'm gonna like really mess up continuity now because you've messed up continuity with just a jacket, but that's fine. That's within the video. I'm gonna mess up continuity on an even bigger level because I'm gonna mention something that will come out in a future episode.
Ooh.
But in a future episode, in one of our chats with Zhao, one of the Rus
time traveling.
Yeah, with a Rus alumni, he will mention a quote which I will now quote back. Right? Basically. The beauty of a flower is not diminished by knowing about its structure and its function, right? It's this idea that like, as people interested in STEM or science, the world doesn't become less interesting to us the more we know about it. If anything, it becomes more beautiful and more exciting the more you understand how simple the processes behind it actually are, right? So yeah, I agree. You don't have to lose the magic, and you shouldn't. With explicit teaching. But that was a good chat, I think.
That was fun.
Yeah,
I hadn't thought about OC in a while, so.
Yeah, that was a real nostalgia flashback.
I do miss the OC class, and I do miss my OC teacher.
Yeah. So hopefully we can pick this up in the future and keep going through more of these themes. Hopefully you guys found this interesting as well, and hopefully you weren't just like yelling at the screen, be like, "You guys don't get it! I disagree with you."
Yeah.
But yeah.
Straight up. Thank you for watching. Subscribe to the channel for more future videos and podcasts, and potentially we'll move this to other platforms as well.
Yes, we're looking into that. But no, I think that's it.
Okay, dope.
Cool. Thanks, everyone. Bye.
Bye-bye. Yeah. Okay, but let's stop here because that's actually a perfect point to stop. Oh crap, I just lost my train of thought. We're gonna edit that out.